Hello and welcome to this very basic kind of study video for chemistry. So, chemistry is basically just like the study of the elements and how they react to each other and how they work together and stuff like that. And the elements are just atoms that all have their own unique properties and weights and names and stuff. And so, here I have a simple little drawing of a element. So this element is helium because it has 2 protons in the nucleus and 2 neutrons in the nucleus and 2 electrons. So the different parts of an atom are the nucleus and the orbiting electrons. And so the electrons have a negative charge in orbit about the nucleus, and the nucleus is made out of protons and neutrons, and the nucleus has the majority of the mass. And in real life, these electrons are way farther out, so they provide the majority of the volume for the atom because they take up a lot more space. Now, if we throw in more protons to the nucleus, then there are going to automatically be more neutrons and electrons that follow. And all these patterns, all the different number of protons in the nucleus make up the different the different elements. And so what happens is, if we throw in another, I lost my pencil. If we throw in another proton into the nucleus, then there's going to be another neutron as well, and then another electron will follow. Now, the way the electrons stack up is in energy levels. Now, these levels can hold different numbers of electrons. So there's the first energy level, which can hold 2 electrons, and then a second level, and the second level can hold 8 electrons. Then the third level, they can hold another 8 electrons, and then the third and fourth level can both hold 16 electrons. Now, if we were to since we threw in another one of each, we have to throw in another electron. And now, we have made lithium. And so, all these different atoms are put together in the periodic table of the elements, which I'm going to go over now. Now, all these different elements are put together in this table. And this table has a lot of patterns that aren't, they don't make themselves apparent just looking at it. But when you start to look at the elements themselves and the properties that they have, you'll see the patterns. So, if we are looking at this table up and down, you'll see that they have similar colors, except for over here. And so when we look up and down, these are called families. Families have the same number of valence electrons, and valence electrons are the number of electrons on the outermost energy level of the element. And so this first column, the first family, is called the alkali metals. The second family is called the alkaline earth metals. And then this whole section over here is called the transition metals, and they kind of throw it all off because they don't behave like they should. They're naughty elements. But the alkaline earth metals have 2 valence electrons. The next family is the boron family and has 3 valence electrons. Carbon family has 4. The nitrogen family has 5. The oxygen family has 6. What's it called? Halogens have 7 valence electrons, and our noble gases have 8 valence electrons. Now, and they always have a full outer level. And when we are looking at this left to right, these are the periods. And when we look from left to right, the element becomes more or less active. And so we're starting off on this far left corner. Since they only have 1 valence electron, they want to bond with other elements. And as we move right across the table, they become more and more lazy, kind of, because they have more electrons and they're just kind of fine with it on their valence electrons. So, and when these guys want to join with one of these guys, then that is chemical bonding, which I'm going to go over now. So what chemical bonding is when two of the elements kind of donate electrons to each other to make a new compound. And the reason that they want to join is they want to fill their outermost ring with the electrons. And so one of the most common bonds, one of the most commonly known bonds is table salt. So what table salt is made out of is sodium and chlorine, NaCl. Now on our table here, everybody wants to be like these noble gases. They want to have 8 valence electrons. And our valence electrons are the number of electrons in our outer energy ring. So if we take Na here, sodium, since it's in the first family, it's going to have 1 valence electron. And chlorine, and since it's in these are halogens, it's going to have 7 valence electrons. What we're going to do is write the abbreviation for both of them, and so that's going to be Na and Cl, and draw the number of valence electrons it has, just with little dots. So I'm going to draw 1 valence electron for sodium, and 7 for chlorine. Now what's going to happen is chlorine is going to want to kind of borrow one of sodium's atoms. It's one of its valence electrons. And so what's going to happen is this atom, I keep on calling them atoms, I mean electrons. This electron is going to go over here and make chlorine have 8. And so now what's going to happen is, because sodium is losing a negative charge, it's going to be a double negative and end up positive, so it's going to be Na is going to be getting more positive, so that's a 1. And it's going to be going 1 up, and chlorine, because it is gaining a negative electron, it's going to be going 1 down, so it's going to be 1 minus. And so together that Na and Cl make NaCl, table salt. Okay. So that's just some very basic chemistry. Hope it could help you out. Thanks. Bye.